For about 6 months, I have been running my entire house and garage off-grid using this pair of Growatt inverters and this auto transformer. During that period of time, I've gotten a lot of questions from all of you asking me about some safety concerns that you have. Well, in this video, I'm going to address some of those questions. As well, we're going to make some modifications to the wiring setup and make it safer. So here we go. Hi, I'm David. Welcome to my channel where I like to DIY renewable energy and energy efficiency projects. Early in 2021, I purchased with my own money 3 of these Growatt brand inverters, the Auto Transformer, and a bunch of these Gyll brand batteries. They've been rebranded to EG4, but right now I've got 30 kilowatt hours of lithium iron phosphate batteries. I've got 2 of the Growatt inverters left. I used to have a third Growatt inverter, but I realized I didn't need 15 kilowatts worth of inverting power, so I gifted one of those to a friend of mine, and I have a video on that if you'd like to see how I built that system. So I've been running 2 Growatt inverters, which is a total of 10 kilowatts. I have them turned off right now because they make some fan noise, which would really mess up the audio for the video. Each inverter is 5 kilowatts. The auto transformer that I'm using is a 5 kVA from SolarEdge. They're getting harder to find, so Signature Solar has sourced some more from Growatt. They're still 5 kVA, still auto transformers, so they basically do the same job. Now I'd like to remind the viewers that this is a DIY channel, so I've done this myself, and I like doing things myself. So I'm just showing you how I did it, and yeah, a lot of this wiring is temporary because I keep messing with it. I keep tinkering with things and making fine-tune adjustments. When I first wired up this auto transformer, I actually had it feeding off of the circuit breaker box using a standard double pole circuit breaker. So each of these inverters fed into the circuit breaker box, back feeding through one circuit breaker. And then off the same bus bars inside, I had one circuit breaker that fed out to the auto transformer, and then one wire for the neutral feeding back into the neutral bus bar of the panel. Now that just made the most sense to me when I first set it up. But there were lots of viewers who rightfully so had a concern that what if, for whatever reason, this circuit breaker shut off inside this box, we would lose the neutral because we'd no longer be supplying power to the auto transformer. Now if that happened and these inverters were still supplying power, then there is the potential that we could fry some electronics. So certainly we'd want to eliminate that as a possibility. So what I did in the meantime is I wired in a terminal block. So that's right here. This black terminal block is a way that I can wire all of these things hardwired in. So right now it's hardwired into the auto transformer. Each inverter is hardwired to the terminal block. And then I have one output. This is a 63 amp double pole circuit breaker which breaks both L1 and L2, which feeds the circuit breaker box. Now during this setup, I've had a bunch of different testing that I've been doing with this auto transformer because I still don't want the possibility of overloading the auto transformer. However, I should note that since I operate off-grid, I'm pretty aware of what my loads are. I love making spreadsheets, so I list out all my 120 volt loads, I list out all my 240 volt loads, and probably most people who are going off-grid probably have a clear idea of what their loads are. Now what that means is, for me personally, in my setup, I'm not loading down this auto transformer. I mean, it hardly sees any work. Since I have 2 inverters, if I had 2 auto transformers going to the terminal block, there's really, at that point, I would say it's unrealistic that me or anybody who visits my house could overload them. But still, what if you don't want to purchase another auto transformer? I mean, I don't need another one in my setup in my house. So how could I make this safer with my current setup? I got a temperature sensor that has a little relay on it, and this was $2 or $3 on eBay or Amazon. This is a little temperature sensor, so this goes inside. Auto transformer goes over, say, 60 degrees Celsius. I could close the relay and send 12 volt power out of this, 12 volt DC. So I could use a little battery like this, little temperature sensor, and then I could use a little shunt trip circuit breaker like this one, paired up with the double pole circuit breaker. That way, if the auto transformer is getting too hot, the shunt trip shuts off the double pole breaker. So that's a way to do it. Now I would have to move some of the wiring off the terminal block to do that setup, but that was the way I was going at first. However, this seemed like a lot of stuff that might go wrong. You know, what if the battery dies? What if the something malfunctions on this little circuit board? So I wanted something that was a little bit simpler or more robust. What if I buy a 32 amp circuit breaker like this, a single pole, which could feed off the neutral of the auto transformer? It could go next to the double pole for the 240 volt, and I could join the handles together. I could, the handle here is hollow, so I could run a steel pin through the handle and then make the two trip. So I spent a lot of time plowing through the manuals for these different brands, and I was trying to find some document that said something about joining the handles together of one circuit breaker to another circuit breaker and how I could do that safely. What was the maximum number of poles, for example? And I could not find any document that gave me guidance on that. So I came up with another solution, which I think is the winner. This is a triple pole circuit breaker. This one happens to be Nader. It is UL, so it has the UL sticker right on the side. Each pole is 32 amps, and each pole can break 240 volts AC. So the way that I'm going to hook this up, I'm going to have L1 from inverter 2 going to one pole, L1 from inverter 1 going to another pole, and the neutral off the auto transformer going to the last pole. Now this breaker is a 32 amp circuit breaker, and the auto transformer says continuous load on the neutral is 32 amps. So in order to overload this auto transformer, I'd have to be pulling a continuous load on a single phase without any load on the other phase. And the reason is because if you load down both phases, they balance each other out and they don't overload the auto transformer. They don't even go through the auto transformer. But if I did that, if I completely loaded one phase without any load on the other, I'd have more than 32 amps on the neutral. It'd be going through this, and eventually it would trip this circuit breaker according to the trip curve. When it did that, it would kill both inverters from powering the terminal block. So I think this is a winner. So we're going to try installing this, and I'd love to hear from all of you if you think this was a good idea or not. And I'll leave a link for this in the description below. Let me give you an overview of the wiring. You can see up there they have it listed as ground, line, and neutral, but I'm going to call it ground, L1, and L2. So red is L2. All the L2s come together at this terminal block, but the black ones, they used to run to this terminal block, but I'm moving them. Likewise, I used to have these wires going to the bottom of the circuit breaker, and they run up into the circuit breaker box, which feeds all the loads, which everything's off right now. So what I'm going to do is take these out, and I need to put them in their right spot. So for the reds, the L2, this is just going to move up, and I'll drop it in the top. Now the black one feeding to the panel is going to go directly off the terminal block. But in order to feed this particular block, it's going to be fed with the two poles. So I'm going to take these jumpers. We're going to bring both, these are L1 and L1. We're going to put them to the terminal block on the output side of the breaker. But coming in the top of the breaker is going to be L1 from this inverter and L1 from this inverter. So we're going to run them through. So this is feeding the same phase, same L1, L1. These two wires are coming from inverter 1 and inverter 2. They're going to come in the top of this breaker. Out the bottom, we're just going to jump to this pole. The last one here is going to be for the neutral. So I need to move this neutral wire, which goes from the auto transformer into that box. I'm going to move it to the output side of the breaker. And the input side of the breaker, we're going to run a brand new wire from the auto transformer to the breaker. Okay, I think all the wiring is done and both inverters are on. So let's check our voltage. So going from this one, which is the common, we're going to check to inverter 1 is 240 volts and 240 and nothing right here because we don't have the circuit breaker on. Now we'll try turning the circuit breaker on. And now we should have 240 volts here. And we do. We have 240 volts. So now that we have 240 volts here, let's check to, yep, 120. And over here is also 120. Now let's check at the circuit breaker box. So I turned on this circuit breaker. There's nothing attached to the output. It's just so that we can measure the voltage. And we have 240 volts. And then if I go to the neutral bar, let's see here. There we go. Yep. So hopefully you can see that. I got it on the neutral bar, and then 120 and 120. So it all looks good. So I'll turn that one off, and this is the water heater. So let's turn that on. And 44%. So the water heater is working. Excellent. So if we overload this neutral wire, it'll flip that off, which will kill all the output. So now with that off, let's check the voltage again over here. And no voltage. And to the neutral, no voltage. Well, there it is, you guys. I'd love to hear from all of you in the comments below if you think this is a good idea or not, if you're using one auto transformer with 2 or more inverters. Now again, if I was using a 1-to-1 ratio of one auto transformer to one inverter, then I wouldn't worry so much about this. But this is just in the situation that I have where the potential is 10 kilowatts of inverting power to 5 kVA of auto transformer. So I think it's a viable solution. Now let's say you have one auto transformer and 3 inverters. They do make a 4-pole circuit breaker. So these are MCB or miniature circuit breakers, and you can get them in a 4-pole design as well. There was another question that a lot of you were asking, and that is there a neutral to ground connection inside the inverter? So I'm going to disconnect my wires here, and we will check for continuity between the ground and neutral. This is Growatt inverter number 2, and I just labeled these wires, so I'm going to disconnect them, and then we'll be able to pull off these, but these are really easy for me to know which is which. And after I removed the 3 wires, I gave all 3 screws a good tightening on those terminals. So now we've got continuity on our multimeter with a beep, so we should hear an audible sound if there's a connection. Just to demonstrate that, I can hear the sound. Hopefully you can hear it as well. So ground is the terminal all the way to the left. Right there. So no ground to line connection and no ground to neutral connection. I don't hear any beeping. And let's just check over here to this one, and no contact between L1 and neutral. All right, so there we go. No continuity between ground and neutral on the Growatt inverter that I purchased from Signature Solar. Again, I can't say if that's going to be the same case with every Growatt that you might buy from China directly, but at least for the ones that Signature Solar is selling here in the United States, there is no connection. Not on mine, at least. So I'm going to do that one more time with the multimeter in frame of my phone, because I noticed that it wasn't. So all the way to the left is ground, and then to L1, nothing, and to neutral, nothing. And then we'll check to neutral to L1 and nothing there as well. All right. So there we go, no contact between ground and neutral inside this inverter. I've also had a lot of other safety questions in relationship to using these inverters when they're tied to the grid. I can't address those questions because I don't tie this to the grid. I have 240 volts output from each inverter, but I don't have anything on the input side. Those terminals are bare. And that's how I run this. So I don't run it on grid, and I just can't address any of those questions because I don't have the experience behind it. And the other thing is that I can only address questions in using this exact model Growatt inverter from Signature Solar. I didn't go on eBay or AliExpress or Alibaba or something like that, and I didn't try to save a few bucks by buying it directly from China. I bought these from Signature Solar, the American distributor, and they put in a lot of pains into making sure that these were good. So that's how I'm coming at this. So if you have some other situation, where you're grid tied or you're buying these directly from China, I'm sorry, I just don't know the answers for you because I don't have the experience for it, but I did buy these from Signature Solar. Now, as far as that ground to neutral connection, I thought I had checked that in one of my early videos when I first put this on the workbench with a circuit breaker box, but that was a long time ago, so good thing to double check and make sure that I don't have that connection. And all of the wiring really should be in conduit, so I'll be cleaning that up in the future if I decide to keep it like this. But if I decide to keep it long term, I will be putting all of this inside a DIN rail box like this, where when you open it up, it already has a DIN rail inside of it, so the circuit breakers will snap in place. So thank you everybody so much for watching. If you enjoy these videos, please like, subscribe, comment, and share. Oh, and something else for a future video. This will be fun. Let's see here. This is a used isolation transformer. Now, it took several months of searching on Craigslist before I found one, and I bought this about 4 months ago, and it has still been sitting around waiting for me to try it out. I did have that whole hiccup with that other inverter that did not work out for my system, and so I'm back to trying some different fun things with the Growatt. So I can't wait to try out and test an isolation transformer instead of the auto transformer. So it's just another fun way of trying to build an off-grid solar system. And this will probably have more losses than the auto transformer, so I probably won't want this running all the time, but it's something that I want to try and actually measure and see how much the idle losses are going to be. A couple of other things to note about this setup. Currently, I'm only switching one of the hot legs and the neutral. When I feed this panel, it needs to be fed with a 2-pole breaker breaking both of the hot legs. So that could be done with back feeding one of the breakers on here.